Thank you, Michael. As Michael mentioned, I'm part of the Automated Driving Lab at OSU. The Automated Driving Lab, we work on the full stack of autonomy. So we have our own automated vehicle, and we work on both motion planning, everything from motion planning to simulation. So we have a lot of technical, mechanical, and electrical engineering work, but we've also started to get into transportation-related work with our project with ODOT, and that's what I'm here to talk about today. So before I break my computer, can I get an idea of who in here, is that your system back there, or is that my computer?
It's your computer, I'm not touching it.
Okay. Yeah, so let's get this done before my computer breaks. Is anyone in here a transportation modeler or planner? Or has anyone used V2X Communication, DSRC, before?
A little bit.
A little bit? Okay. So I'll try to explain those concepts as we're implementing them a bit. I want to talk a little bit about how we've built a simulation environment to simulate UAVs in a normal traffic simulator called PTV Vissim. But I first want to explain why you want to simulate UAVs for traffic purposes in the first place. Obviously this session is about unmanned aerial vehicles and visualization. And as other speakers have mentioned, there's been a lot of work for using UAVs to monitor traffic. If the video plays, the state of the art is pretty impressive using drones to automatically tag and categorize vehicles to get vehicle counts and trajectories. UAVs can play a large part in gathering real-time data. And that's only the beginning. Drones, if you've heard, there's been a lot of developments just this year with companies such as Aerobotics and UPS achieving FAA certification to fly beyond visual line of sight, so to fly a drone autonomously for package delivery and other uses. Just in the past 3 years, state DOTs have, in 2016 there were 0 state Department of Transports that were using UAVs for their operations, whether it's for data gathering or other purposes. And this year, there are over 36 states now using UAVs. Ohio is one of them, and we're working with ODOT on their UTM project, so Unmanned Aerial Traffic Management project, where they're building out active and passive radars to be able to monitor, track, and make sure that drones don't run into each other, so that companies like Amazon or Uber can implement their own drones along high-capacity corridors in Ohio. So there's been a lot of work for drones to actually operate autonomously and collect data, and that already exists. But at the same time, the technology is obviously, I want to offer a small video to show how important autonomy is for drones. And do we have the ability to get sound, or is that on my end as well?
Sound is on.
Do I have to push something up here to get the sound? Or do I have to plug in a sound jack?
We'll just go.
Yeah, the sound makes it a lot more funnier. It's going to ruin my punchline. Let's try one more thing. So this is actually a fun video when there's sound. But the point is that even in the consumer market, there are drones with high levels of autonomy rolling out. And these drones have the ability to collect data and fly autonomously. And those drones are going to be the type of drones that are implemented in a future UTM system. So all this that you're seeing is all filmed autonomously. There's no controller. It's all controlled via a smartphone or a speaker, a beacon, sorry. So the main point that I'm trying to say is that UAVs are coming, the technology is already here, and they're going to have impacts on transportation systems, whether they're flying along high-capacity corridors or within cities. And there aren't many tools out there to simulate drones. But before talking about simulation, I also want to talk about the importance of vehicle-to-vehicle communication. At the moment, there's a lot of standards in the automotive space. If you're a researcher who's used data from DSRC units before, you'll know that there's something called the basic safety message, where vehicles will send their velocity, acceleration, and position data to other vehicles. We are looking into the possibility for drones to also be connected via these DSRC radios so that they can enhance their data collection of vehicle trajectories using ground truth data from the vehicles themselves. So no longer are you trying to take a video of traffic and find all the cars and label them using a number of video processing tools, but you can actually augment those estimations of car locations and trajectories with these vehicle messages directly from the vehicle. So there are a number of developments within communication for drone use. Commercially, right now, all commercial air vehicles implement a technology called ADS-B, which is the BSM of the aerospace world. But a paper from NASA this year and last year from NASA Langley and NASA Ames was showing that ADS-B will not be able to support the number of drones that are going to be in the airspace in the future. And so they're recommending the automotive standard, DSRC, to be used on all future drones. So we have drones that are being deployed, and we have communication technology that both NASA is recommending to enable autonomous flight in our cities. So with that being said, it's important to be able to simulate both drones and communication in future traffic scenarios. Few use cases. As I mentioned right now, you can supplement video data from drones to get microscopic traffic parameters for research and simulation. But in the future, drones are going to be used for real-time management. And by that, I mean, right now you have signs on highways giving dynamic speed limits or giving notices of queues. In the future, you won't necessarily need to invest in high-cost permanent infrastructure when you can use existing aerial vehicle traffic to send and transmit messages to connected cars. So the possibilities with drones is that you don't need to install permanent communication infrastructure. You can use them as a mobile radio to go and give messages to cars about potential speed limits or even to implement dynamic speed harmonization. So the first video, I think, is a long time coming. I want to give a quick overview of the simulation environment that we've built. If anyone has heard of PTV Vissim, it is the standard traffic simulator used by most industry professionals to simulate microscopic and even macroscopic traffic. Vissim doesn't have any capabilities to natively simulate drones or traffic, and so our lab, or rather I have built custom abilities to run a simulation environment that we can watch right now. And it's not a problem that there's no sound because the video doesn't have any sound anyway. So what you're going to see is actually a city in Germany running a multimodal traffic simulation. And I've used the library that I've developed, the simulation environment, to add drones directly to that existing simulation. And so you can see that all these orange cars will have drones that are tracking their trajectories. And so I call it a drone following mode. And you can easily populate simulations with different densities of drones and visualize what it looks like to operate drones in an urban city or on a high-capacity highway corridor. So there are a number of questions that you could ask that you might want to visually assess before getting into technical details. You can ask questions like, would Amazon delivery drones, given a smaller drone size, would those be scary to operate within a city environment? What about an air taxi like Uber? What does it look like to have an Uber air taxi flying in our city? And so you can look at a number of different use cases, from simulating different densities of drones to different sizes of drones, and immediately visualizing what those use cases would look like. And I think there's one more simulation here, just to give a sense of the. Okay, one second. So this is actually showing the simulation real time. To actually show that you can run this simulation environment. You don't need to have a post-processed rendered video. You can actually run these simulations in real time and watch drones fly past. I just find this funny because it's a traffic simulator that we've implemented both the simulation of dynamics of drones and also the visualization. And so when you've been working with Vissim simulations for a long time running traffic, it's just weird to see drones, obviously. So this runs. I think this was running about 2 times real time, 2 times simulation speed. And so you can get good performances while running relatively large-scale simulations with these drones. Let's skip forward. And then here's a quick example of what it will look like if you want to throw in some really large drones that you definitely would not want to operate in this sort of environment. You can imagine a drone the size of a car operating in a dense urban environment. And you can easily get to a visual sense of what would make sense or what looks like a Star Wars invasion. So I think we get the gist. We can move on from that. This is the general architecture. I guess I don't think anyone is super in-depth into using Vissim, but the main point I want to make is that you have PTV Vissim that runs as the normal software, and this add-on environment runs as a simple Python library. So all that you need to do is, if you're already running scripts in Vissim, you simply add this Python library. And it can be used or implemented with almost any simulation that you currently have running. I want to show quickly how simple it is to create the simulation that I just showed you. This is all the code. So I know a lot of people have been talking about graphical user interfaces. I haven't developed one of those yet for this platform. But it's really simple to create a drone simulation in this simulator for real-time simulation. Another quick example of so this is on a highway corridor outside the Transportation Research Center in Columbus, Ohio. Which is where part of the high-capacity corridor is for the ODOT UTM project. And so again, you can define a UAV base and then start to ask questions like, how long would it take a UAV to be deployed to an emergency scenario on the highway? And so there are a lot of questions that you can start asking with the simulation environment that you previously couldn't do with any software package out there. I haven't really been able to talk about communication. We haven't implemented a lot of the visualization aspects of communication, but this library also gives the ability to communicate vehicle to vehicle, a general vehicle to vehicle communication protocol, and then you can export that data for further processing in a lot of the environments that we've seen today. So that is all I wanted to cover, but I'm happy to take questions on possible use cases of drones or any questions about the simulation environment. Thank you.
Question.
Yeah.
So the simulations all have the drones following the roads.
Yeah.
I mean, the advantage of drones, especially last case they go into an emergency situation, just straight flight. So how does that's kind of the real world application, they fly straight lines.
Straight there.
They fly at different levels, so like
Yeah.
kind of stopping at signals.
Yes.
I mean, they would theoretically be flying at different levels, wouldn't they?
Exactly. So the use case that I was showing here was more of a car following use case, and so you would never see car following that level of density. There are a few use cases of car following for UAVs, whether to provide additional sensing capabilities for a car or whether to assist with emergency response of an ambulance or a police chase. However, you're correct. The thing about following cars is that it was a bit easier to code. I can just tell this drone to follow this car. If you want to define custom trajectories, you can do that. However, you then need to implement some logic about how you want the drones to fly, how you want to manage drone traffic. I mean, NASA is still trying to figure out how they're going to implement drone traffic management. And so this simulation environment gives the capabilities to simulate different trajectories, different altitude, and all those use cases. But you're right, that would never really happen in real life. Yeah.
Any other questions? All right. Thank you very much, Garrett.
Thank you.